Hey everyone, this is a video for Unit 4, Solving for a Variable. We're in Lesson 3, Solving for a Variable in an Inequality. This video will be going over your note pack, so if you have your notes with you, go ahead and get those out, and you can go through the examples with me. At the top of those notes, there are steps for solving an inequality, and the first step is to get rid of parentheses. The second step, you need to combine like terms on both sides, put the x's together and the numbers together. I have x's here, but it can be any variable. Number 3 is to move all variables to one side, and number 4 is to move all the numbers away from the variable by using the inverse operation to get rid of the numbers around the variable. So get rid of the parentheses, combine like terms on both sides, get your variables on one side, and then solve for the variable. The only difference between solving for inequality and solving for equation is that when you divide or multiply by a negative number, you switch the inequality sign. So, for example, if you had the problem 3x equals 6, to divide by 3, or negative 3x equals 6, to get x by itself, you would divide by negative 3. So that would be x equals negative 2. If you're dealing with an inequality and you have negative 3x is greater than 6 and you divide by negative 3, then the answers, the number and the variable stay the same, but this sign switches to be less than. So that's the only difference when you divide or multiply. So if I had x over negative 3 is greater than 2, then if I multiplied by negative 3 on both sides, I would switch that sign. The inequality switches. Here's a little cheat sheet for this is less than. This less than with the line underneath it is less than or equal to. Then you have greater than, and then greater than or equal to. Okay, so now some examples. It says 4 times x minus 5 minus 3x is greater than 7x plus 1. So the first thing I do is get rid of parentheses. So I distribute the 4 through. So I have 4x minus 20 minus 3x is greater than 7x plus 1. So the second step was to combine terms on each side. So some of you like to put a line there. So what would go together on the left side is 4x and negative 3x. That would become x. Then you would have minus 20 is greater than, and then 7x plus 1, nothing goes together over there. So now I have to get variables to one side, and most of you are used to moving it to the right. So what I would do here is subtract 7x. Over here, this would go to 0, so I would have 1. I subtracted 7x, and I didn't multiply or divide, so we're good there. X minus 7x is negative 6x, and then negative 20 comes down. Now we need to get rid of everything except the x. So how I get rid of the minus 20 is I add 20. So I would have negative 6x is greater than 21. Now to get this x by itself, I would divide by a negative 6. And anytime you divide by a negative 6, that's when the difference comes in. This would cross this out, and I would have x. 21 over negative 6 would reduce by 3. So this would be 7 over 2, and I would have a negative on it. I can leave the negative on the bottom or put it on top. But since I divided by a negative number, I have to remember to switch that sign. So what this means is that any x value that's less than negative 7/2, if I put it in for x here, here, and here, it would give me a true statement. So when you have this problem, 3x equals 6, and you divide by 3, that's going to be x equals 2. That is the only number that goes in there to make that statement true. I can only put a 2 in for x to make this a true statement. So this is the only solution to this problem. But when we get here, any number less than here gives me a true statement. So to graph that, I'm going to just go on a number line, and what the graph is for is just to show you where the solutions actually start. So negative 7 over 2 is equivalent to negative 3.5. So any x value less than negative 3.5. Negative 3.5 would be here. It cannot equal negative 3.5, but it can equal anything less than that. So all the numbers that are shaded in blue would give me a true statement if I plugged it in for the original inequality. Okay, so let's do the next one. So the first step is to get rid of the parentheses, so distribute the negative 2 through. Distribute a negative 1 through. And now we have to put like terms together. So on this side, negative 2x and negative x would go together to be negative 3x. And negative 10 and negative 5 would go together to give me negative 15. And that's less than 4. Now get x by itself. So I add 15. So I get negative 3x is less than 19. 4 plus 15 is 19. Now I divide by a negative 3. So this one, if I divide by a negative 3, that becomes x. Over here I have negative 19 thirds. That's not going to reduce by any numbers, and I'm going to put the negative on top. But since I divided by a negative 3, the inequality switches. So just for graphing purposes, this is going to change to x being greater than negative 6 and a third. So when I'm graphing that, one, two, three, four, five, let's say that's negative 6. So if it's any number greater than negative 6 and a third, here's negative 6 and a third, and then it goes this way. So all the numbers this way on this number line would make it a true statement. All right. Next problem. Get rid of the parentheses by distributing. Make sure you got your signs right. Pause the video if you need to, but you just take the 4 through, take the 7 through. Then you clean up both sides. So on this side, the 4x has nothing to go with it, but negative 4 plus 6 would be plus 2. On this side, we would have 7x. Negative 28 plus 3 would be negative 25. So once again, most of you are used to moving the 7 over, so I'm going to do that. If I subtract 7x, to get my variables to one side, this side becomes negative 3x plus 2 is less than or equal to negative 25. To get x by itself, I need to move the 2 and the negative 3, and the first thing I want to move is the 2. So I'd have negative 3x is less than or equal to negative 27. And divide by negative 3. So I get x. This is going to become 9 over here. And this sign switches because I divided by negative 3. So once again, any number larger than 9 would give me a true statement if I plugged it into the original inequality. To graph that, I'm just going to say here's 0, and let's say that's 9. So 9 would give me a true statement, so I shade that as a solid dot, and anything greater than 9 gives me a true statement. So all the numbers in red are solutions to this inequality. All right, number 4. I need to first get rid of the parentheses, so this side would stay the same. Distribute a 3 through. Now clean up both sides. So on this side, 4x minus 8x would be negative 4x plus 6 is greater than or equal to 3x minus 6. Now I need to get x's to one side, so I'm going to subtract 3x. So this would be negative 7x plus 6 is greater than or equal to negative 6. Now to start getting the x by itself, I would subtract 6. So that would be negative 7x is greater than or equal to negative 12. And then divide by negative 7. And that's going to be x is less than or equal to, because I divided by negative, so that flips. And then 12 over 7 doesn't reduce, except this becomes a positive. So what that means for graphing, for graph-wise, that would be 1 and 5/7. So to graph that, any number less than or equal to 1 and 5/7. So if this is 0, 1, and 2, 1 and 5/7 would be somewhere right here. It's equal to that, so it could equal 1 and 5/7 and give me a true statement, but anything less than that could work as well. And those are the examples in your notes.